Welcome to classes on organic chemistry. Today's class is Haloalkane and Haloarenes. It is higher secondary 12. So today's class is important only because of the fact that it is the textual solution. It is important for exam point of view as well as for entrance point of view, because a lot of questions are often asked from textual solution. So minutely follow the question. So I am going to start a lot of solution, and which I have selected specifically for those problem which I think is not possible for you to solve. So first of all, I want to solve in dark does not react, but in bright light it gives monohalogenated product. The question is very simple, but to solve out the problem it requires a bit thinking beforehand. You see, solution of this one, this is the formula of CnH twice N. It seems it is alkene. There is two possibility. Number one, it may be alkene or it may be cycloalkane, because both cycloalkene and alkene has the formula CnH twice N. Am I right? So from these two options, we have to first decide whether it is alkene or cycloalkane. So from the question you see, it doesn't react in dark, means it is not alkene. It is not alkene. Had it been alkene, there would have been double bond, and in double bond, when it reacts with, the question was C6H5 in dark does not react with chlorine. Am I right? Make it some correction. So had there been any double bond in dark, it would double bond chlorine would have added in double bond one carbon. Since it doesn't react with chlorine in dark, means it doesn't have double bond, that is it is not alkene. The option is cycloalkane. Now let us see if it is cycloalkane. This is nothing but this. So carbon 5 and hydrogen 10. Am I right? So when it reacts with chlorine in bright sunlight, it will give the answer as this. Now question, monohalogenated product, because CH2, 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 all the carbon are in same type. Am I right? So since all the carbon hydrogen are of same type, so in one position Cl, either this, any one position will give the same product, though it is monohalogenated product. The first question is over. Sorry, iodobutane. How will you prepare iodobutane? Number one, from iodobutane from butanol. Butanol, very simple question. So what is butanol? CH3, CH2, CH2OH. From this we need iodobutane, means here we need one iodine. Am I right? So simply you make the reaction with this, you are getting CH3, CH2, CH2, CH2I. That is iodobutane. Very simple. Nothing. Iodobutane from 1-chlorobutane. 1-chlorobutane. That is CH2, CH2, CH2. This is one, and this is a very famous reaction we have already got in the name reaction. Acetone. acetone. Answer is again very simple, CH3, CH2, 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 I plus NaCl. Now it is Finkelstein reaction. Finkelstein reaction. It is a name reaction. I have mentioned in the name reaction at the beginning of my chapter in class 17 or 16. You can see it. I have explained this one. But today I will add you something more. Sodium iodide, when reacts with, there is halogen exchange reaction. Actually, there is exchange of halogen. That's why we have got iodine in place of chlorine and NaCl. Now the question is, why we are using acetone? Acetone is a solvent. In the solvent acetone, only sodium iodide is soluble and sodium chloride and sodium bromides are not soluble. So when sodium iodide is soluble, this facilitates the reaction to occur. Am I right? It is dissolved in acetone, then iodine reacts and there is exchange occurs. Am I right? But in the reaction product, we are getting sodium chloride. Since sodium chloride and sodium bromide are not soluble in acetone, it get dissolved. Sorry, it precipitated out in the reaction mixtures. So the volume decreases as it precipitated out. According to Chatelier's principle, the reaction is go forward. So equilibrium shifted towards right as more and more sodium chloride is dissolved down, and more CH3, CH2, CH2I will fall. Am I right? And this reaction is very important because in due course of time again we are getting this one. From but 1 in CH3, CH2, CH double bond CH2. From but 1 in we need to prepare iodobutane. Iodobutane, but 1 in. So but 1 in will be made reaction with HBr. Am I right? Now one point here I am mentioning. Here you see bromine peroxide. Again you make it Finkelstein reaction. You are getting CH3, CH2, CH2, CH2I. Now here one point is to be followed. Here you see HBr, it is Markovnikov addition or anti-Markovnikov addition. If you add HBr sorry, simply, then negative part would have attached with CH, that carbon here would have attached here if we do not use peroxide. We have used peroxide because intentionally we have done this to get alkyl halide bromine at the end. So it is anti-Markovnikov, that is carbon having double bond, carbon having more hydrogen, the bromine will get attached with carbon having more hydrogen, and in case of Markovnikov rule, the negative part of bromine would have attached to carbon having less hydrogen. It would have attached here and hydrogen here, but we intentionally done so to get bromine at the end. It is anti-Markovnikov, because if we get in this way alkyl halide, then we can use sodium iodide and acetone. In earlier cases Finkelstein reaction I have already mentioned that I will get this one, or otherwise you can methanol plus Ki, also you can use this one, methanol Ki, same thing, you will get the same thing. The point here is this, because in all type of this preparation here we see whatever the reactant is given, that reactant is converted into alkyl halide first, except one reaction is converted to alkyl halide, because whenever we get alkyl halide there is some polarity. Without polarity of alkyl halide, or there is a lot of scopes when you get alkyl halide. When you get alkyl halide, sometimes we change it by cyanide. Likewise, we will proceed. So our main motto is to get alkyl halide, more polar compound substance, and out of this we will get a lot of option to convert this one. So this is the main things we would get alkyl halide, and here the option is alkyl halide or bromine should be here or bromine should be here. That depends upon the demand of the question, because iodine is at the end, so bromine should be at the end. So we have used here anti-Markovnikov peroxide effect or crash effect. Am I right? Next one is CH3 Br CH3I SN2 mechanism. Which one show faster? Answer CH3I, because this is better leaving group, as compared to bromine and iodine. Iodine in the group, same group, is bigger than bromine, so iodine is better leaving group, so it will follow faster SN2 mechanism. Next one is CH3 whole thing 3 CCl and CH3Cl. Again answer CH3Cl, because more the steric hindrance, less is SN2 mechanism possibility, because this concept again will come in need later on. Here CH3, CH3 is there. When 3 CH3 there is a chances of carbocation formation. Chlorine will get released and carbocation will be 3 degree carbocation, and it will be stable. And when there is steric hindrance, means CH3 bulkiness occurs, there is Cl release is very easy, so that carbocation is the stable carbocation, and mechanism will follow SN1 mechanism. So here more the chances of SN1 mechanism, and here more the chances of SN2 mechanism. Now excellent factual question is the dehydrohalogenation. You are given CH3 and bromine C2H5 ONA C2H5OH. So you were asked to write the product, and here I have written in the very beginning dehydrohalogenation, means there will be the release of one hydrogen and one bromine. So before coming to this one, let me explain a bit. I will explain this one so that you can explain other two very easily. You see how I solve this one. It is a bit hard one. You can't easily solve it without knowing the fact. You see, for our convenience, let us write this as this. This carbon is alpha, and here there is hydrogen and hydrogen. This is beta. Again, this is hydrogen and hydrogen. This is also beta. So the problem is that in one substance, on one compound, if there is two possibility, again this is beta. There are two possibility of beta and beta. We are dealing with dehydrohalogenation, means beta elimination will be there, because in the product C6H5O, this is negative, this is plus, so C6H5O negative will be a base, is a strong base. This base, what is the property of base? Base is a substance which will extract hydrogen from beta position. Am I right? And that leads to elimination product. Am I right? So that C6H5 will extract beta position. Now question is that where, which beta, this beta or this beta, these two beta are same, this or this. So let us see, if we say this base, I am not writing this one, this base, am I right? If this base abstract hydrogen from here, the answer will be like this bond will be withdrawn in this way and this will be this. So you are getting answer in this way. Am I right? This is one answer. And another way, if you see, if you want, if you write beta here, you give beta here, and if this beta abstract this hydrogen in this way, so that bond will be done in this way. Am I right? And the bromine will be released out this way. So what's happened in the second case, you are getting the product as double bond and this remain intact, CH3. Now question is, and this is minor. Now how can we decide which one is major and which one is minor? So I am not discussing about the CJF rule. I have mentioned in my last class 17 CJF rule in elaborate. Am I right? So here besides CJF, what CJF tells that the substituted product will be majority, where there is CH3 group is more. But here I will explain you one of the interesting fact. If there is 2 alpha, 2 beta carbon, if there is 2 beta carbon, 2 beta hydrogen, then more stable or more majority of the product will be that where beta hydrogen is eliminated from carbon having less hydrogen. Carbon having less hydrogen. Here the carbon having 1, 2, 3 hydrogen, and here carbon has 1, 2 carbon, 1, 2 hydrogen. So when abstraction from carbon having less hydrogen occurs, that this is always major, and abstraction of hydrogen where carbon has more hydrogen is minor product. Always important one, keep it in your mind. So next one is CH3, CH2, CH3, CH3, Cl, again same, C2H5ONA, and in alcoholic solution. Again there is abstraction of beta hydrogen. Now you see, again you are getting the same problem. In one step I will do this one, you can understand. If this is alpha, then that carbon is beta, again that carbon is also beta, that carbon is also beta. So you see, to remove hydrogen, to abstract hydrogen by the base from this and that is same. Am I right? Because of hydrogen are of same nature, but competition is removal of hydrogen from this carbon and from this carbon. Am I right? So a bit earlier I have told that if you remove the beta hydrogen from carbon having less number of hydrogen, is the more stable one. So our answer will be CH3, CH3, CH, CH3, Cl. Your this one will abstract that hydrogen and that bond will be inclined and that will go in this way. Your answer will be CH3, CH3 double bond, CH. Other product you can write yourself. You remove one hydrogen from this one and give double bond here, and you remove this one. Am I right? I am writing the major product. So is of the same type. C2H5 ONA C2H5 OH. So here you see, again this is alpha, this is beta, and this is beta. I have got two beta. Am I right? So my first explanation was that beta carbon which has less number of hydrogen, if you extract one hydrogen from here, that will give you major product CH3 C CH3 CH3. Say I am writing here H, this is been abstracted, and like this CH3 C CH3 double bond CH CH3. This will be your major product. You can write other product, again you extract one hydrogen from here, you write CH2 double bond CH and withdraw this one. Conversion. So what is ethanol? CH3 H2OH. At the very beginning I told you, so make it alkyl halide. So thionyl chloride CH3 CH2 Cl. Now question is that the chain has been increased. So what we do here is, we have obtained polarity. Now option is left out, in which option we will apply to get this one increasing of chain. So increasing of chain will be done by CH3 Na. So you may think, where from we got this one? I will show you. Because in first year you got acetylene is weakly basic. So if you made to react with sodium is a strong base, then that acidic hydrogen, this or that changes. So we will get answer is CH triple bond CNA, sodium acetylide. Am I right? So this is side reaction. You may keep it in your mind. From first year I have written this thing is this. So now what's happened? This is negative and this is positive. That negative will get as nucleophile, will attack here and that will release. So what we get here is CH3 CH2. Get attached means is a bond C triple bond CH, bond C triple bond CH. We have got, sorry, we have got methyl prop butane 1. Next one is ethane to ethyl bromide. It is very simple. Because if you made to react with bromine in presence of UV light or at higher temperature of about 500, more than 500 degrees centigrade, we will get substitution. CH2 one hydrogen will be removed by bromine. So it is very simple, nothing to explain, you know it very well. Propene to nitropropene. Now let us write the structure first and see what we need to do. CH3 CH double bond CH2 CH3 CH2 CH2 NO. We need this compound. Am I right? But let us forget everything. When you get the substrate, our first aim is to make it alkyl halide, to make it polar. Then we will test apply other possibility to get this one. So first part CH3 CH double bond CH2, we will add HBr. Now question is that when we will HBr, then B will come to this one according to Markovnikov rule and H will come to this one. because this is plus and this is minus. Minus will get attached to the carbon having less number of hydrogen, and plus attached to carbon having more hydrogen, number of hydrogen along double bond. Am I right? Now, since NO group is at the end, we need bromine at the end. So we will use here peroxide. So we will get CH3, CH2, CH2, Br. Peroxide effect. Hydrogen will get attached to this one and bromine with this one. Now, silver nitrate, very easily we can replace it. Answer is CH3, CH2, CH2, NO2. Very simple. The fact lies here. First you convert this one. So in conversion alkyl halide, we need bromine here or at the end. That will be dictated by observing that nitrogen is at the end. So we need anti-Markovnikov rule. Peroxide is to be used. So next one, toluene to benzyl alcohol. Benzyl alcohol. Now let us see. This is toluene and this is benzyl alcohol. We see that one hydrogen, let us make it aryl halide first. As I have told you earlier, make it halide. So we will do what? Then we will check out another possibilities. Say bromine boiling, we can make it boiling. Am I right? Boiling. So that chlorine will replace side hydrogen of methyl group. So one hydrogen of this methyl group will be replaced, will get aryl halide, that is benzyl chloride. Now it is very simple, we need to get OH. So potassium hydroxide aqueous. If it is alcohol, elimination. Very often I used to mention this one. If it is alcohol, it is elimination, and if it is aqueous, it is substitution. So we will get substitution product very easily. Nothing to explain, it is very simple. So first concept is you make it alkyl halide or aryl halide. Am I right? Here we have made it aryl halide or benzyl chloride. Am I right? And then we have replaced it by potassium hydroxide. CH3, CH double bond, CH2, CH3, C triple bond, CH. Propane to propyl. We should get triple bond. Am I right? To get triple bond, first of all, we will add bromine. Let's see. CH3, CH, bromine, single bond, CH2, bromine. Am I right? So now we need to remove these two bromine to get this one. Am I right? So a bit earlier I have told you, if we get potassium hydroxide, use potassium hydroxide alcoholic, then it is elimination. And elimination, we maximum time we use beta elimination. Am I right? So how does this occurs? Answer is very simple. CH3, C triple bond, CH. The answer is simple. But how we have got this one? You see, CH3. With respect of this bromine, this is beta carbon. So one hydrogen from this will be extracted. Am I right? One hydrogen from this will be extracted. This is beta carbon extracted. So this will be extracted by base and this will be inclined here and this will be removed. So we will get CH3, CH double bond, CH. This is bromine. Am I right? Now with respect of this bromine, your beta carbon is this. So next step, this bromine is extracted and the bond is would done in this way, and that is coming this one. You are getting finally this product. Those who cannot understand is very simple. Just you write this one, because to first of all, when one bromine is removed, then beta hydrogen is abstracted. That bromine is removed, then beta hydrogen is abstracted. We are getting triple bond propyne. So propene to propyne. Am I right? So methyl bromide to acetone. It is a bit hard. You see, the carbon chain has been increased. So, and we did not convert it alkyl halide because it is already alkyl halide. Am I right? So, to make it more reactive with Grignard reagent, will made to react with cation, alcoholic. So, we will get methyl cyanide. Because when you get methyl cyanide, then this bond is withdrawn with more electronegative nitrogen, and this become partially plus and this become partially minus, so that we can use Grignard reagent of desired type CH3 Mg Br, because only one CH3 is already here. We need another CH3. That's why we have chosen one Grignard reagent, which is methyl magnesium bromide. And another reason is that in my earlier classes I have told, when cyanide is made to react with CN group is made to react with Grignard reagent, it gives CO group. Am I right? So since here is CO, that choice of this Grignard reagent and introduction of cyanide group in place of bromine is justified. So we will do what? CH3C double bond N, and this is minus. We know Grignard reagent is C is minus, this is plus, nucleophilic attack. So minus will get attached with this one. So we are getting CH3, and since it is minus, plus part will be attached with magnesium bromide, and if you make it acid hydrolysis, so bond will break in this way, we will get in this way, we will get ketone CH3C double bond of CH3, and this is how we get methyl bromide to acetone. Benzene to diphenyl. So let us see benzene. That is benzene. We first introduce aryl halogen part. So we will write bromine FeBr3. So one bromine will come. So we'll get bromobenzene. Am I right? Alkyl halide. So we know the fitting reaction. Am I right? When twice sodium diether is used, then this twice, I am writing this way, bromine plus twice sodium, bromine it is fitting reaction. I have explained it earlier, till I have done you for your understanding. So it is benzene to diphenyl. Again we have converted this reactant to aryl bromide or aryl halide. Then we have taken the help of fitting reaction. So this is all about conversion of alkyl halide from your chapter. Now there is another question. Next one is, Grignard reagent is prepared in anhydride state, means without water. because Grignard reagent, if water is present in preparation of Grignard reagent, then say this is Grignard reagent R MgX, chlorine, bromine, anything. If you give water, if there is any water in the Grignard reagent, then this is negative and this is positive, then that positive part will be attached here, it will give you alkane. Am I right? So if Grignard reagent, during the preparation of Grignard reagent there is water molecule, then it will instantly give you alkane. That's why in the preparation of Grignard reagent, the preparation is done in anhydride position where there is no water. Give the product. CH3, CH2, CH2, chlorine, NaI, acetone. Very easy. Within a second you can do this because it is Finkelstein reaction. CH3, CH2, CH2, CH2I, halogen exchange. Simple. Next one is, if it is made to react with sodium hydroxide in presence of water, means hydrolysis. Very simple. Sodium hydroxide in aqua solvent, it will give you substitution reaction, that here there will be OH, CH3, C, CH2, CH3, this. Very simple, nothing to explain. Next one is CH3, whole thing 3, CBr, potassium hydroxide, alcoholic. This is a very important reaction. Very often the student gives the wrong answer. Here you see let me write it in this way. Am I right? Potassium hydroxide, alcoholic. So very often students make mistake when they see that there is OH. Am I right? So they replace this one. So CH3, 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 OH, tert-butyl alcohol. Am I right? The answer will be wrong. The answer will be base will abstract that hydrogen and bond will incline in this direction and this will be removed. The answer will be CH3, C double bond, CH2, CH3, or you can write CH3 here. It is all the same. Now let me explain a bit what happens here, why it happens so. Because here potassium hydroxide in alcohol, say it is ethyl alcohol, say it is ethyl alcohol. What's happened? This is plus, this is minus, that gets joined, so you are getting water and C6H5 O negative. Now you see it is a strong base. It is a strong base. OH is not there. OH is now here involved with alcoholic solution alcohol and gives rise to a strong base C2H5 O negative. And what is the function of the base? The function of the base is to abstract hydrogen. So this will abstract hydrogen either from here, 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 all the case same type of hydrogen. So when one hydrogen is abstracted, bond will be inclined in this way and bromine will go away. This will give you the eliminated product, not substituted product. But had there been potassium hydroxide aqueous, then it would be SN1 reaction. It would have given product would have been CH3, CH3, CH3OH had there been aqueous, because here OH would have been a nucleophile. C6H5ONA plus C2H5Cl It is Williamson's ether synthesis. So this will be very simple one. This will give C6H5 or C2H5. Very simple. C6. I am not showing the mechanism. I am showing you the way how to get. You see C6H5 or C2H5. This is ether. It is very simple, nothing to explain, because it is phenoxide ion, and this is alkyl halide. Yes, you are asked to give the product, to explain the product. Now let us explain what happens here. Potassium is an ionic salt. Potassium cyanide is ionic salt. So in water it breaks into in this way. And instantly it is ambident ligand. In my last class I have mentioned, there is possibility of attacking through C as nucleophile and through N as nucleophile, because C has got negative sign and N has got negative sign. It will attack the substrate either through C or through N. Since it is an ionic one, it breaks into in this way. If it is silver chloride, if it is silver cyanide, it is covalent compound, so it has no way rather than attacking through this one. It is only one option is left. The product will be NC. But here there is two options, either through C or through N. So what's happened here? CH3, CH2, 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 Br, am I right? And this will attack that carbon through C or that carbon through N. Since CC bond is more strong, stable than CN bond. CC bond is stable than CN bond. So attack will be through this. So this will attack in this way, and this will be SN2 mechanism. Am I right? So you are getting CH3, CH2, 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 CN. Am I right? So this is SN2 mechanism, and there was two options of attacking the nucleophile through upon this carbon through C and through N. Since CC bond is more stable than CN bond, so attack will be through C, and that through C means C is attached to that carbon and bromine will leave out. Am I right? So this is the explanation of the product which is given in the reaction when the reaction is carried out in alcoholic media. C6H5 Cl, C6H5 CHCl, C6 is of hydrolysis. You are asked to explain the ease of hydrolysis out of this. See, first C6H5 CH2Cl, then when it loses this chlorine it becomes carbocation, and in case of second one C6H5 CH, then here chlorine C6H5, if it loses chlorine you are getting C6H5 CH, this C6H5. Both will follow SN1 mechanism, but you see this is 1 degree and this is 2 degree. Now we have to explain ease of hydrolysis, that which one will be easily hydrolyzed and which one will not be easily hydrolyzed. And ease of hydrolysis depends upon the stability of carbocation out of these two one. So you see 1 degree and 2 degree. 2 degree carbocation is more stable than 1 degree carbocation, as the plus charge is delocalized on two benzene rings. Here this plus charge is delocalized in one benzene ring, so it has got more stability than this one. More the stability of carbocation, more easily the compound will be hydrolyzed. Hence this one will be easily hydrolyzed. Part is again conversion, and this is propene to propanol. Let us see CH3 CH double bond CH2. We need CH3 CH2 CH2 OH. So at the very beginning I told you, when there is reactant in conversion, when there is um, um, the reactant is of this type of reactant, whatever the reactant is, we will first make it polar by converting into alkyl halide. So first of all, without thinking, let us try to convert it into halide by adding HBr. So now there is a fact, whether Br should be here or Br should be here. Since OH is here at the end, we need Br at the end, so we will use peroxide. So we will get CH3 CH2 CH2 Br. Then it is very simple. When alkyl halide is there, potassium hydroxide, if it is aqueous, then we will replace this one, we will get CH3 CH2 CH2 OH. 1 bromo 2 bromo propane, 1 bromo propane to 2 bromo propane, CH3 CH2 CH2 Br CH3 CH Br CH3. So we see it is already alkyl halide. So let us make it elimination with potassium hydroxide. So that hydrogen will be removed from beta carbon, CH3 CH double bond CH2. Now very simple, we'll add bromide. We'll use here, we need bromine at the second position, that bromine should go here. That is simple Markovnikov, we do not make any change. CH3 CH Br CH3. Toluene to benzyl alcohol. I have done it in another reaction, the same thing. This is this needs a very little thinking, because here we will make it aryl halide simply by bromine boiling to make bromine. In this way there will be side change reaction, substitution or reaction of bromine or chlorine, whatever you use, then it is potassium hydroxide aqueous, it will be again substituted in this position, nothing, benzyl alcohol to this. Mind that when CO, before thinking I am telling you, when COOH, we need this one, because when cyanide is there, we will make it acid hydrolysis, and this on acid hydrolysis, it is very simple, known to everyone, this gives you COOH. No option is left. When COOH, cyanide group is there, we need COOH. Am I right? So by any means we should introduce cyanide here. So let us start. First of all, we halide aryl halide. So we will react with PCl5. So this will give you CH2Cl. Am I right? When alkyl halide is there, we need Cn. So we will use KCl and we will get CH2Cl, which on acid hydrolysis will give you the desired product. Am I right? So you should think COOH cyanide. Cyanide will come if there is halide. So we will make it halide by PCl5, then KCl, then cyanide, then on acid hydrolysis. Next one is aniline to chlorobenzene. It is very simple. Aniline to chlorobenzene, because benzene diazonium chloride you quite very earlier, HNO2 NaNO2 plus HCl. When we mix this one, we get HNO2 in situ, and when this reacts, we get everybody of you know benzene diazonium chloride, and it is known to you all. Next one is CH3 CH2 Cl. You are asked to convert it COOH. Again, it is very simple. When halide is there, we will make cyanide. We will make to react with KCl. We will get CH3 CH2 Cl, which on acid hydrolysis it gives CH3 CH2 COOH. Very simple. Chlorobenzene, this seems to be a very simple one. I am taking the critical ones and I am not explaining the easy ones. Seems to be very easy, but it is a bit tough. First of all, we need to replace chlorine. So we know it will give substitution reaction, nucleophilic substitution reaction, and very harder condition. If you use this, we will get phenol. Am I right? So one part we have got. We need nitro. Now there is a question. We will use dilute HNO3, so that major product will be OH is orthane para. Major product will be this. Now question may arise in your mind that why not nitrating mixture? Because very early, very beginning, we know when concentrated sulfuric acid and concentrated nitric acid is used, it gives a nitro. NO2 group is electrophile and it is a nitrating mixtures. But why we are using here dilute HNO3? This is because of the fact that OH is a strong activating group. It activates instantly orthane para position. So if you use this one, this mixture HNO3 and sulfuric acid mixtures to get NO2, so NO2 will instantly enter in this position, this position, this position at a time. We will never get this one. That's why we have here used HNO3. Hope you have understood the class with utmost interest. I will be coming up with next class with most interesting topic.